or as summarized a review of week 1 as I can possibly make it. I'm open to interruptions. So if you have any question, if there's something that you feel you want to explore a little bit further, just chime on in. This is a very casual session. It's going to last an hour, but generally lasts a little bit shorter if you have it lasts a little bit longer if you have questions. So feel free to ask as many questions as you have. The idea is to just go over the content from Sprint1. But if you have any questions, don't hesitate to ask away. What I'm going to share with you are some of the components of exploratory data analysis, visualizations, and essentially structuring your data when you're working with multiple data sets. So everything that we covered in Sprint1, we will go over today based off of what we go over. I'll see if I can present some new stuff. But again, I think at this point, everyone in the class, this is a first for a cohort, has actually gotten 100% on the Sprint challenge and over 80% on the Sprint assessment. So everyone in this room is already set to move on to Unit 2, which means you can either take advantage of the Sprint review sessions, or you can take advantage of the time to build your own personal projects. You can start taking practice sessions with the general coding assessment, and you can eventually, I recommend again that you take one shot at the general coding assessment for yourself. So try to structure your week in a way that makes the most sense to you and the type of projects you might be interested in building. If you'd like other resources, Randy, I'm going to go ahead and ask you to recommend the books you just referred to on the recording, if that's okay.
Yep. Naked Statistics by Charles Whelan, I think. Statistics. Yeah, Charles Whelan. And then the other one was, I think, brought up earlier in a previous class, The Signal and the Noise by Nate Silver.
Those are two classics. I also want to throw the book How Charts Lie, Getting Smarter with Visual Information by Alberto Cairo. He's a University of Miami visual journalist. Mostly he's just essentially showing you how you can manipulate charts in a way that's deceptive, and how to read charts much more logically. So a lot of fun stuff there. And it's all these 3 books are very easy reads. They're books we have in our, they're books I typically have in my, even if I haven't read Naked Statistics yet, it's a book I have in my, somewhere in this house. All right, so let's get started. If you want to do some coding along, we're going to go ahead and just open up a brand new, fresh Google Colab notebook. I'm going to go ahead and share my screen. You're going to have a zip file on your Slack channel for today's lesson. Don't know what that is. Let me leave that there. Let's go with, what's another one? Cameron, just shout it out.
Confidence data skills.
It's Confident Data Skills by Kirill Eremenko.
What's it about? What's it about?
So that one is not. It doesn't go more on the coding aspect, but it goes more into building a stronger analysis and figuring out the importance of data sets, and kind of just what to, depending on, whatever the project may be, just kind of what you should look for, what results you should, look for, and how to present those. So it's more of just presenting the data, and less on just the cleaning and creating all the functions and stuff to analyze the data. So it's more just about being able to present that in a professional environment.
Excellent. Love it. I'm gonna add it to my list. Beginning of the month, next month, I got a little bit of a budget for more books, so not going to stop me. Excellent, folks. Thank you, Cameron, and thank you, Randy, for those. Yeah, that's I'm always looking for added books to collect. So for today, you're going to want to go ahead and download that weather CSV zip file. It is in the format of a zip file. So Colab itself has some Jupyter magic that I do believe is available in your local Jupyter notebook as well. But what I'm going to ask you is create a new notebook in Google Colab or Jupyter Notebook, whatever you prefer to do. I'm going to call this one Sprint Review. Sprint Review 1. This is DS. Technically, this is DS40. So when you upload the file onto Google Colab, one interesting thing you can do, just going over to downloads, I'm reading in my weather zip file, which I've clearly read in multiple times. So let me see if I can just read this one. Yeah, all right. So I'll just read that in. Your version of weather CSV will probably not include that version 2. So I'm just going to read in that file as a zip file. I'll rename it up here if I can. This is just me trying to get my version of the CSV file consistent with yours so that the code lines up. Cool. So files are uploaded. We have it inside our Google Colab. If you work in Jupyter Notebook, you just need to download it and have access to it. But exclamation points are usually referred to as one way to kind of call a specific command behind the scenes with Jupyter Notebook. And some of those commands are programs like unzip. Let me be very clear. A lot of these, if you want to do something specific, like for example, connect a data set directly to Kaggle, this will be relevant to you down the road, starting next unit. There are a lot of easy ways to download Kaggle data and connect your Google Colab notebook to Kaggle websites and Kaggle pages. So something to keep in mind, all of this can be found through simple Googling. So I'm going to go ahead and just unzip, because it's currently working as a zip file, my weather CSV file. You'll see it'll return a command of inflating. It's creating a brand new folder inside my directory, which allows me to access that notebook after a little bit of a pause.
Might you hit the refresh button under files?
I might have to.
I know it doesn't like to refresh on its own.
Yeah. So yeah, the refresh button. Thank you, Randy. That's the folder with the refresh thing on the side. And I'm going to use my usual packages of pandas as PD, NumPy as NP. Not entirely sure if I'm going to use NumPy, but just in case. I'm going to use matplotlib as PLT, and finally Seaborn. Okay. Couple quick things that I want to sort of talk about really quickly when you're spending time on Kaggle, seeing other people's coding. You're going to see a lot of code that, depending on the environment, ends a code cell with plt.show. Now, this plt.show is generally a line of code that you use when you want to represent more than one subplot on a specific code cell. But every so often, I see this type of code included in like notebooks when it's not quite necessary. I'll give you an example in just a moment when we actually start working with visualizations. But one of the things that you'll see otherwise used is the matplotlib inline command at the end of your code cells. Now, with most versions of Jupyter Notebook and Google Colab, this line of code is extremely unnecessary because most visualizations in matplotlib are by default going to appear or present, or essentially going to be, they're going to pop up as a rendering of your HTML in Jupyter Notebook or Google Colab notebooks. Now, that doesn't mean that this isn't necessary. Sometimes when you're working in VS Code, other coding environments, you can expect to need to include matplotlib inline to demonstrate, to output visualizations as part of that environment. So I'm just kind of giving you that heads up. I haven't shown you a lot of code with matplotlib in mind. It's a lot less necessary as part of notebook standards, but just in case you see this, it's the reason it exists is for the use of Python in other environments. So, okay, files are read in. I'm using the packages I want to use today. Let's read these in as separate documents just to see what they look like. Calling my weather CSV file on its own. That's not even what it's called. Weather CSV, that's the name of the folder. Inside the folder itself, I'm going to navigate over to weather1. This part probably tracks, makes sense. I have one column that I don't think I'm going to be using very much. I have another CSV folder or another CSV data set called weather2. So may not quite need the unnamed columns. Those seem to be like an extra column. But say, for example, I wanted to not necessarily use these as separate data sets. What is probably the best way to combine these two data sets into one larger data set?
PD concat.
There you go. So we can either concat them if we want, if we're comfortable knowing that the two indexes are essentially exactly the same. In this case, it does look like 0 is the same date for both sets of values, and it looks like we have the same set of values. In an event where we're not entirely sure, however, Randy, in the event that, for example, what if we don't have the same number of rows, or the values might potentially be different, what would we use instead?
An inner join.
A join, that's correct. So I'm just going to go ahead and drop these column names. Before I start dropping these, just want to actually make sure I get the name of those columns correct. Go ahead.
The other thing that you could do with that would be to actually set that unnamed 0 as your index.
Yep.
Because that looks like what it was is when somebody exported it to a CSV, they did not specify something as the index, so it got added as an extra column.
Correct. So we can go ahead. So we can either drop it, or like Randy's saying, we can let's go that path, because I do want to show how you can set the index. I'll show you the two ways you can set the index. When you read it in, you've got a parameter called index column, and you can label what you want your index column to look like. The other method is a pandas method called setIndex. And setIndex just actually does the exact same thing. It's just an external method outside of the PD read CSV tool. So I'm going to go ahead and take this one data set read in as I'm aiming for it. Read that in as weather1. My secondary tool, my secondary data set will be weather2. Just going to read this both in at the same time and have those ready to go together. Because here, then, we can concatenate. Now let's merge this just to make sure we have the exact same values in both for both data sets. So merge my two data sets along an inner merge. We could have just as well concatenated them. Are there any questions about merging or concatenating, or the difference between those tools, those two?
In this case, if we were to have concatenated, would it have duplicated the date column?
Find out. So what would have happened is that it would have axis equals 1. concat whether I've got a code error somewhere. Yep, these are not strings. So the reason it does not concatenate the reason it does not, well, I'm sorry, it does double up the dates for you, because all that concat is doing is essentially stacking the two data frames next to each other. So essentially, up until this point, up until this first point, it's weather 1, and after that, it's weather 2. Any questions about the parameters for merging, left on, right on, the differences between the two columns? When in doubt, remember, you can always open up the documentation in Google Colab or Jupyter Notebook, or just read the instruction manual. I highly recommend reading instruction manuals. It's a lot of fun. All right, so let's call this my weather data set. I'm just going to save this as is. I will share this code with y'all in a code thread.
Do we want to name the concatenated one the weather one or the merge?
No, absolutely not. Sorry. Thank you. Just going to actually comment that out. Thank you. So that one, we're set to go. So we have a data set. We know a few things that we can start to do with this data set. Kind of the general EDA is very straightforward, right? We want to know a few details about the shape, the structure, what kind of data we're looking at. One of the tools you might find yourself using fairly frequently is weather.columns, because weather.columns essentially returns all of the column names as a quick go-to list that you can eventually use for whatever purpose, whatever cleaning structure. Say, for example, I wanted to actually rename all of my columns into like uppercase. I can actually do for I in weather columns, essentially create this as a loop. I can essentially reassign these as new column names. Keeping this simple, is an empty list. What I'm doing is taking the new column names, making a loop that appends every single value as a capitalized name. And, excuse that correction, that new column name is now my name of new list. So why is this, why essentially engage in this? Well, this is just kind of having a little bit of fun, because all this does is essentially renames my columns into something a little bit more structured. But because I understand how to use weather.columns, it means that I can rename my columns into that new tool. So this is going to be weather.head to return the first 5 rows. So quick, easy way to transform and rename all of my columns in one quick series of steps. So we've got weather.head. This returns the first 5 rows. We've got weather.tail, returns the last few rows. And just a quick glance at our data set to help understand like what the values are. And we can begin to understand from using options like weather.info. We'll return all of the information about our given data set. And with that, we can begin to see like the data types, how many null values. In this case, I'm just going to go ahead and tell you right now, there are no null values based on the fact that there are 43,000 entries, and all of the entries essentially find the same way. But if you have thousands of columns, that gets a little bit tricky. So it's important to remember the is null trick dot sum. It's a great way to just return all of your columns, the amount of null values in all of your columns. We've talked a few about some of the packages we've used previously. So that helps for our numerical values, some of our numerical columns. It may be helpful to kind of recognize some of the other tools that are available to us, like weather.describe, which on a quantitative level essentially returns the 5-point statistics for all of our values. This is pretty straightforward. It helps us recognize the different components of the of the distribution of said values. And we can also recognize for the not quantitative values, things like values like wind direction. We may potentially need something else. And I'm not a fan of the necessarily of the describe all, because although describe all is helpful, kind of messy as a specific set of values. But with this information, the information you can get from describe all, you can also get by calling a value directly. Like for example, wind direction, which was our specific column that we were referencing earlier, can be returned with .unique to return all of the individual values within wind direction. Questions so far? Okay. Well, some of the other packages that we actually spent some time looking at, as well as part of the work we did as part of the work we want to know about our different value sets, is using the different tools in different packages like Seaborn or Matplotlib to gather visual understanding of our value distribution. So Seaborn's pair plot is an excellent tool for looking at the distribution of those different sets of values. What does this do? It actually compares all of your quantitative values against each other. So it essentially creates scatter plots and histograms of your individual values. And it actually takes a little bit longer to run for that purpose, because as a pair grid, it's calculating and creating a general visualization for every single tool. And I'll let that run for a second. But if you ever want to kind of get a quick idea of your different distributions, pair plot is great, because it takes a look at all of your tools and it returns a potential distribution for all your sets of values, including pollution, rain, snow, wind speed, all of those things. And we can see the linear, or we can see the histogram distribution for all the values against themselves. This part makes sense? It's pretty straightforward. But I don't know, I don't remember if we covered it in class. But it's a set of distributions that can essentially give you a quick picture of what your potentially linear values might be in this data set. The other tool that you're going to find yourself using fairly often is the weather.core tool, which returns a Pearson correlation for all values to each other. Essentially, this is relating to like, what is the linear expectation we can have for one value to another. And with a heat map, so SNS heat map, and if we wanted to annotate those values, we can return a graph that is a little bit small. Let's talk a little bit about the tools we can use to improve to make some changes to our graph. Because this is Seaborn, it's important to remember that Seaborn itself is built on top of Matplotlib. That means that a lot of the tools that are built into Seaborn can essentially be combined together. There's a few kind of changes you might have to find yourself making at times. Like, for example, if I wanted to make this a little bit bigger, I'd have to call the figure itself and adjust the fig size. Whoops, that's going to be thin. Whoops. This is measuring on an inch by inch scale. So essentially my figure is going to be 12 inches long and then 1 inch wide or 1 inch tall. Let me go ahead and make a correction there. So this makes a little bit more sense as a visualization tool. So because I've called my figures based off of the PLT figure, I can essentially make adjustment to the map to any visualization that's on the same cell. I can create a title, call this heat map, whatever you want to call it. And that title can be adjusted to font based on the parameters of each one of the matplotlib tools. So font size can be, let's make this 20. Let's make that adjustment. And I've got a little bit of a large text. You want to get rid of this text here at the bottom, by the way. You can use either the plt.show as your tool, and you'll see it removes the it'll removes the text. And I'll explain the reason why. But this plt.show in a Jupyter notebook, not exactly necessary because a semicolon will do the exact same thing. Now, a quick thing to note, the reason this text pops up, it's because it is specifying that these are AX objects that you can then essentially reassign, say, for example, from the heat map object, you can reassign and come up with other changes to the tool. See if I can get the drop-down values to pop up. So AX object, that AX object has a few other values we can begin to call directly. And then this is where you begin to mix the matplotlib type tools. A lot of this, by the way, I don't know if I shared this with y'all earlier. Python bar graph database. Python graph library is the name of the place. Nope. Python graph gallery. I like this tool a lot, just in general, just in case I haven't referred to it. If you want to create visualizations kind of from scratch, all of these are available with a bunch of different packages that you could potentially use. I think this is this with Plotly? Let's find out. Let's call that map object. It uses GeoPandas for this. So it uses a few other packages. I think we talked about using Plotly in this class. So you have a couple of different tools available to you, but note that there's a bunch of different packages you might find yourself using throughout time series. Cool. One more thing, you can also set the style of your visualization from the very beginning as a default object. And that's essentially with the plt.style. You can use a specific tool to call what kind of package you might want to read in. That's not it. What's it called here? Use. Oh, it's used. The use goes outside. Whoops. Okay. Because it is a module. So plt.use style. And you'll note that there's a slight change to the visualization in this case. I've got a few different tools as well. There's classic. Note that this all builds on different parts of the matplotlib axis objects. So now that we have these tools, what is something else we can do? Well, based off of the values that we're working with, there might be, like, what we might be interested in doing is essentially tracking the change in pollution over time, or perhaps we could try to determine whether some of these objects, like temperature, dew, pressure, I think snow and rain here appear to be categorical values of some sort. But we could potentially determine just how much pollution occurs as time goes on. But in order to do that properly, we need to recognize what type of object my date is. Because unfortunately, our date as a datetime object doesn't do much for me. Like it's existing as a string. If I wanted to calculate it as a time value, I need to actually convert it into an object. So for that, pandas datetime to datetime is a tool that will essentially convert a value that it recognizes as a time value to a datetime value. And for that, I'm going to call my weather.date column, which is spelled date uppercase, and convert these into datetime values. And making that conversion helps us return a few of the parameters as far as datetime values go. Because as a datetime value, we can now consider this object a datetime. And what does that help us do? Well, if it's a datetime value, we can start to call the objects directly by the type of period that we're working with. So say, for example, if I wanted to convert or call a specific period time, I can call my objects based off of a month. Or I could call these objects directly to their month values. So note the difference. One calls the month itself. Let me go ahead and return that back to period. So essentially this goes till that specific period, but I can also call a specific value just to the day itself, or I can call the month of that value directly. Note that there's a slight difference between the two things. Oops. Questions about datetime values yet so far, or how to convert these? Okay, so let me call my month values. Well, let me call my year values for this. Create a data set from this value. Let's keep this consistent. Year, it's going to be that, and call the year value. Because from here, I can start to look at my year value and determine, maybe I want to calculate how much pollution we've seen over the years. Well, weather group by on a year-by-year basis will return, let's say, for example, an average value for all my quantitative values. But if I wanted to return this based off of a specific column, I can call my pollution column. And from here, plot my values. Can take this a little bit further by adding a couple of other lines of code to my earlier value and just call the months itself. And do the exact same thing for a plot where I track my month values. That doesn't quite look right. This goes together, so there we go. Now note the difference. This is an aggregate for all the values. But let's remember that I can still use that tool I created earlier as another way to interpret these values, because this is an aggregated value of all my months. But if I take a data set that's called, I think this is month, like year month. So now I can take the exact same type of graph, but after doing a bit of engineering on my data set, I can create better graphs that are a little bit more specific to what I'm trying to build in this case. I'll show this last bit of code because that's where I was leading towards. None of this should feel unusual. This should be fairly familiar at this point. But with that said, what questions do we have? Okay. Following up, any questions about using .loc or any questions about navigating a data set? So if we get weather.loc to call the values, do we recognize what we're doing with this?
Is there ever a time that we should be using iloc instead of loc?
Yes. If, for example, you're using or you're trying to identify values based off of the specific index. So in database management, it's any scenario where you're calling a value and you know your data frame might change, like your column name might change, or your index might change. So for example, if you're working with a live date, like if you're working with a data set that's consistently changing, but you know where the index is going to be located, you would want to focus on, you would use iloc to just navigate based off of the indexed value. It's rare, I don't use it as often because class structure usually based on static data sets, but you know, if you're working with SQL or if you're working with a live data set, that can change. The other thing might be if like, hey, you don't know what the name of your column, your first or second columns might be. So for example, I can take iloc and call my first 10 rows. That's rough syntax there. So you can call the syntax values, but then if you just want to use the last value or the last column, you're essentially calling the year month column based off of that. You're essentially like addressing the first few values from there. Or I don't know. Let's call it, yeah, 2 of 3. So you can create smaller data frames from there. Any questions? This one's important because of how we filter for values, but any questions as far as the difference in, let me take a look at this. So weather.describe. Let's take a look at wind speed. Something interesting is happening here. So if I take a look at weathers and wind speed, I think we looked at a histogram earlier. Something here, something about this kind of screams outliers, just based on the hard right skew of this data set. What's the tool we can use for outliers?
Box plot.
There you go.
Can we use Z-score?
Z-score? If you wanted to, yes, you would use a Z-score if you're working with, generally you would use a Z-score in a normal distribution when you're trying to determine an individual values. So in a distribution of values, you use the Z-score to interpret one specific value and how far away it is from the mean. So in this case, what I'm doing is simply looking for outlier values just based off of the IQR. Suggesting we've got a lot of outliers here. So let's see if we can measure anything over, I don't know, let's just arbitrarily put it at 30. Greater than 30. I just want to highlight that Boolean combination of values. This Boolean combination of values is an easy way to create a brand new data set or a brand new column for your data set. Say high wind. Really anything over 30 is a little bit ridiculous to consider a high wind. Let's make this a little bit more realistic. Anything over 65, high wind, is going to be my new column.
You can bring it down a little bit and still call it high wind.
Yeah, pick a time. I pick a date. I don't. The Puerto Rican in me kind of looks at high wind on hurricane levels, so it's a little bit. I recognize my own bias here. I'd say anything over 40. It looks like, according to our box plot.
That's about right.
Yeah, let's call that. Let's follow the box plot here.
That's when they shut all the schools down because the buses can't go over bridges.
At 40, oh, really? Interesting.
I think it's actually like 45, but yeah, we have more wind days than we have snow days down here.
All right, that is
Quite interesting.
That is a nightmare to think about. If your Z-score is greater than 30, you can absolutely, yes. So Nikolai, that's a great question. If your Z-score is greater than 30, is greater than 3, can we also tell that value is an outlier? Yes. So to consider that, we're looking at anything over, that would be a Z-score of greater than, let me check something really quick here. Yeah, we can just do that too. Cool. Let's find out. So to answer Nikolai's question, if our Z-score is greater than 3, can we also tell that value is an outlier? So let's take a look at the Z-score. So in order to actually calculate that, let's bring in from SciPy. I'm going to call SciPy stats. I'm going to call that from stats. You've been using ST. Inside stats, if you're ever in doubt, you can just call your module for a Z-score based off of Z-score. It's been a while since I've had to do that one. And we just need that array. So but we will return how many standard deviations it's going to be. So let's see, that is going to be weather. We were looking at wind direction. Wind direction, no, it's wind speed. Okay. So what this is doing is returning all of the z-score values for our for all of our specific values. And it's essentially returning anything that is essentially it's returning the z-score for all of these values. So I could say, let's take it from there, and anything greater than 3, true, false, false, false. Like that. So we're going to call this weather dot high z. And from here, we're looking at all of our outlier values. So what I'm going to do in a second, because now that I have both sets of parameters, high z, high wind, let's take a look at the sum of those two sets of values. So one was kind of an arbitrary setting up based off a box plot greater than 40, and anything greater than a z-score of 3 will be high wind sum, and then high z. Weather, high wind sum, weather, high z sum. Okay. Yeah. You get fewer outliers with your by measuring off of the height by measuring anything over a standard deviation of 3 standard deviations. So yeah, Nikolai, I'm gonna go your way. Let's go with using high z-score as our outlier values. Let's take a look at that. So if my weather based on high z, now I'm just curious about the data set here. So all that's greater, everything that's greater than 3, I'm just going to limit this to a smaller data set. Nope. Nope, that's the wrong measurement. Anything that where the high z is true. This is still pretty fast, pretty high values. Let me take a look at the wind speed just to look at the distribution of those values.
In this case, because high z is a Boolean, could you omit the equals true?
Let me see. Yeah, you can.
Cool.
Yep. I just left it there. I tend to leave it there just for clarity's sake, but yep. I gotta say, something's up with this. I'm guessing this is knots because this is these are high value. These like this feels high. Measuring wind speed. I'm just curious.
It's not knots.
Yeah.
It'd be 673.
All right. I'm gonna put a pause on that because those are very high values for wind speed. I'm not entirely sure what the measurement is. What is this data set? This is the weather data set. Data set, CSV, wind speed value. That seems the same. Might have been
Where is this for?
This was from Kaggle, so let me just double check the. Okay. Nope, this is a different data set. This might have been it. Nope, that's not it either. Where did we get this data set for? We'll need to double check where we got that data set, but that looks really high. Okay. So with that in mind, though, like what we're like, again, all we're doing is essentially just being curious about the data set and going down a rabbit hole. And that's pretty much what the job looks like when we're trying to clean up the data set and trying to like return the values that are much more significant to us. Because with this set of values, we can essentially remove from our data set any values that we don't want to include. So for example, if we don't want to include our high Z values, this is just trying to classify or not classify anything that is not true. So, but again, that operator is equals exclamation point equals to identify things that are not equal to true. This is just the same as just going for high Z false. However you want to identify it, that's fine. Same thing. But the type of method you would use to create that data set is going to be beneficial to us to determine one distribution about our values and recognizing what kind of measurements we might want from this. So if now we have this lower speed weather, I can assign this into a new object that I can then call from here to interpret my, just to interpret my different graphs. So now I'm curious, wind speed, histogram. Yeah, still a few outliers there, but that kind of tracks. So note, one of the other methods, one of the last methods we talked about, and I think you are all fairly comfortable with this, is that once you have that data set, the .loc isn't just useful for identifying and calculating values one at a time, but you can use the .loc to apply to different filters. So for example, wind direction can be made to identify specific categories as long as you specify that you've got other categories to consider. Or like you can apply other categories. So I can use wind direction and I don't know, month equals to January, like anything in January. And you can use both methods and two separate conditional values to look for values based off of row by row basis, on a row by row basis. Then you can go as deep down the rabbit hole as you like. So this can be another set of values. I don't know. Due. Anything that's due under 10. Cameron points out this could be kilometers per hour. That makes sense. I'm willing to believe that. Oops, syntax. And now I'm down to 333 rows because I need all of my values are specified by these three conditions being met. Okay. Folks, any questions that you might have or anything you might want to go take a look at again? Okay. Unfortunately, that's all I have for you today. If you have any questions, I'm around for the rest of the afternoon regards to projects or essentially any part of the technical process of the GCA. I want to wish you all very much luck this week and the rest of Unit 2 and moving forward. Just because this is our last session does not mean that this is it. I'm still available for any questions you may have down the road with your data science journey. When it comes to getting a job in negotiating, by the way, we are also, by we, I mean my partner and I are also really good at helping people negotiate for better salaries. So my last lesson is when you're doing job interviews, when you're doing through that job process, make sure to always negotiate and always ask for more money than what they initially offer you. And if you have any questions about that, I'm happy to chat with you when that time comes. But I wish you all the best.
Thank you.
Yeah, thank you.
Thank you.
Thank you. Y'all were great. This was a fun lecture. So remember, Nikolai points out, here's one question that just came up. Let me just take that code and bring it in. So remember that just because you remove the first set of outliers, you're still going to get other sets of outliers. You've just redistributed what your average, what your min max is going to be. So there's, you're going to have outliers in any set of distribution based off of how the interquartile measure measures those values. So fascinatingly enough, this one brought back down to 40. So if we use that earlier metric of wind speed of high wind, do I have high wind still? Yeah. So if we measured whether high wind, the values that are true. So those values, all right, I'm making that same, let me just measure it that way. Anything that's high wind where the values are true. For clarity's sake, I'm going to leave that up there. So based off of that true distribution, I take wind speed again, and I get a box plot for this. I'll still continue to. Yeah, like even once you redistribute your box plot, your distribution will continue to like readjust. Like it's still going to have like, oh, but because your interquartile range still remains 1.5. You've just reset what your average is and what the distribution is going to look like. Yeah, good question to end on, folks. With that, hey, have a great week. Let me know how Unit 2 goes later on. Once I'm back, I'll look forward to hearing from y'all. Thank you very much. And take care.
Have a
Take
great
care.
one.
Bye.